All right, so today we're going deep on something that, honestly, affects everyone. Yeah, even if you don't realize it.
Hmm.
Ever heard of GNSS? Global Navigation Satellite System? It's like the backbone of, well, everything. Your
Right.
maps on your phone,
Right.
self-driving cars, delivery drones, even like super precise farming. But
Yeah.
what happens when those signals get jammed?
Oh.
Big problem, right? That's what we're looking at today.
Yeah, no kidding.
You sent over some really interesting research on using AI to maybe like fix
Yeah.
this whole growing problem with GNSS interference. Specifically, we're talking about large language models, those brainy systems behind chatbots,
Yeah.
and how they might be able to, well, analyze and interpret GNSS signals.
Yeah, exactly. And it's a vital topic.
Yeah.
The stability of GNSS is super important. So many different sectors rely on it. Think about it. Any kind of disruption to these signals
Right.
could have a huge ripple effect. Everything from transportation and logistics to financial markets, things that need super precise timing.
Yeah, that makes sense. Okay, so let's get into this research.
Okay.
The idea, I think, is that they're using these LLMs to, like, read GNSS data, almost like they would read text.
Mm.
But instead of words and sentences, they're looking at stuff like signal strength and carrier phase.
Right, yeah. Like teaching a computer to read the fingerprint of a GNSS signal.
Hmm.
Like a detective would look at a fingerprint and spot those little subtle clues.
Right.
The LLM is being trained to recognize the signs of interference, the kind of stuff that conventional methods might just miss.
Okay, that's pretty cool. Now, here's something that blew my mind when I was reading this. They actually showed the LLM images
Oh, wow.
of GNSS signal data. It's like analyzing visual patterns, not just, numbers and graphs.
That is interesting. Yeah, that's where things get really interesting. That's where they use the embedding. It turns that complex visual data into, well, a format that the LLM can understand.
Huh.
Kind of like translating a picture into mathematical code. It captures all the key features.
So they're turning pictures into math.
Yeah, in a way.
Wow. And it works.
It does. It really does.
Wild. So the researchers, they asked the LLM questions about, these specific GNSS snapshots, like what are the characteristics of this signal?
Right.
And the LLM was able to, actually respond with detailed analysis. It pointed out things like carrier phase values, even flagged potential interference if the signal strength was low.
And what's really impressive is it didn't just stop at identifying interference.
Ooh.
It actually outperformed the traditional machine learning methods when it came to actually classifying the types of interference. Like it could tell the difference between, let's say, chirp interference, noise interference, even multi-tone interference,
Wow.
all just from a simple snapshot of the signal data.
So what you're saying is these LLMs, they could be the answer to keeping our important GNSS signals clear.
Is possible?
It's like imagine a self-driving car.
Right.
That can just instantly detect, even avoid areas with bad interference. Makes autonomous driving way safer.
Yeah, and more reliable, too.
And think about financial networks. They could just automatically adjust.
Right.
And protect themselves from these timing disruptions. That changes everything.
It's very exciting stuff. But it is important to keep in mind this is still early research.
Okay, yeah.
So as promising as these results are, there's a lot more work that needs to be done
Right.
before we actually see these systems out there in the real world.
Right. Don't get ahead of ourselves.
Exactly.
I get it. But it's hard not to, when you think about the potential.
I understand. Yeah. And there's a lot more to it.
Oh.
Like the researchers also looked at how they trained the LLMs to interpret these GNSS signals. They use something called prompt engineering.
Prompt engineering.
Yeah. And that's where we can really start to see how these models learn and evolve.
Right, prompt engineering.
Yeah.
I'm definitely curious. Let's dive into that next time, see what these prompts are all about.
Okay. So prompt engineering, it's kind of fascinating.
Yeah.
It's all about teaching the LLM, like how to think about GNSS signals, specifically in a way that helps it detect interference.
Okay.
Imagine you're trying to explain a really complex idea to someone who's never, ever heard of it before.
So analogies.
Yeah.
Example.
Exactly. And that's kind of what researchers are doing with this prompt engineering. They create these specific questions and examples, and it guides the LLM as it's learning.
So it's not just shoving a bunch of raw data at the LLM.
No. It's more about shaping how it actually understands that data.
Okay.
In this case, they had to figure out how to talk to the LLM about, GNSS signals. And that's not exactly everyday language.
Right.
They took those GNSS snapshots, the visual ones, and turned them into prompts that the LLM could actually understand.
So it's like writing captions for the images, but instead of just describing what you see, you're describing what matters from like a GNSS point of view.
Yeah, that's a good way to put it.
Okay, so what kind of prompts are we talking about here?
Well, for example, one type of prompt might be this GNSS snapshot shows signs of chirp interference.
Okay.
What features in the image support this classification? So it forces the LLM to actually look for those specific patterns in the visual data.
Right.
The ones that are linked to that particular type of interference.
Ah, so it's kind of like a super-powered game of spot the difference, but for GNSS signals.
Yeah, exactly. And the more examples the LLM sees, the better it gets at spotting the differences between all those different types of interference.
Huh.
It's like it's building its own little internal dictionary that connects the visual patterns to specific GNSS events.
That's really cool. So we talked earlier about the LLM, actually being able to give detailed responses to questions.
Yeah.
How does that play into this whole prompt engineering thing?
Well, that's where it gets really clever.
Okay.
See, the prompts aren't just about identifying the interference.
Right.
They're also about teaching the LLM to explain why it thinks that.
Oh, so instead of just saying this is chirp interference, it might say something like the carrier phase in this snapshot shows this upward sweep, and that's a sign of chirp interference.
Right.
It's like having a GNSS expert like built into the AI.
Exactly. And that's one of the big reasons this research is so interesting. It's not just about detecting it. It's about the LLM being able to communicate its findings in a way that we humans can understand
and use.
Yeah.
This whole prompt engineering thing, it's really fascinating. It's like teaching a computer to think like a GNSS expert. But instead of years of training, it's all about these well-crafted questions and examples.
It's really powerful. It opens up a whole bunch of possibilities for using LLMs to tackle complex problems.
Right.
The kinds of things that used to need a human expert.
Yeah. So we've got these LLMs analyzing the signals,
Right.
recognizing patterns, even explaining their reasoning.
Uh-huh.
But how do we actually know what's happening inside the LLM's brain? How do we know it's getting things right?
That's a great question. And the researchers actually, they tackled that using a technique called TSNE.
TSE. Sounds a little intimidating.
I know, it sounds kind of complicated.
Yeah.
But it's actually a way to visualize high-dimensional data, the kind of stuff you find in those GNSS embeddings. It makes it so we humans can actually understand it.
Okay, so break it down for me. What is TSNE, and how does it help us understand what's going on in the LLM?
Okay. Imagine you've got this giant tangled ball of yarn that represents, all that complex GNSS data. Yeah. TSNE is carefully untangling that yarn and laying it out flat so you can see all the different strands and how they're all connected. It lets us see how the different data points relate to each other in a way that visually makes sense to us.
So instead of trying to picture a space with hundreds of dimensions, we get a 2D or 3D map that shows how the LLM is organizing everything.
Exactly. It's like a map of the LLM's thoughts where similar GNSS snapshots are all clustered together.
Wow.
So using TSNE, the researchers could actually see how the LLM was grouping the different types of interference based on the features it learned.
So TSNE, it's it gives us a little peek out to the LLM's thought process.
Exactly.
That's amazing. We can see what features it's paying attention to and how it's categorizing all these different GNSS events.
Yeah, it's pretty powerful. But, as cool as TSNE is, what really matters is how the LLM performs out there in the real world, with all its, complexities and challenges.
Yeah, the real world is, it's definitely messier than a lab.
Definitely.
So how do we know these LLMs are actually up to the task? How can we be confident that they'll be reliable enough to deal with, real world GNSS interference?
Well, that's the million-dollar question.
Yeah.
And it's the one that researchers are working on right now. One of the key things they're focusing on is robustness.
Robustness.
Making sure the LLM can deal with unexpected or noisy data.
Okay. So real-world GNSS signals, they're rarely perfect.
Right.
They get affected by, weather, buildings, even trees.
Uh-huh.
So the LLM has to be able to kind of filter out all that noise and still, identify the interference accurately.
Yeah, it can't just be good at recognizing patterns in, like, ideal conditions.
Right.
It has to handle the unpredictable nature of the real world.
But the real world, it's not just messy.
Yeah,
It's constantly changing.
that's right.
New jamming techniques pop up all the time.
Yeah.
The LLM can't just be a one-trick pony.
No.
It needs to learn and adapt to these new threats.
Absolutely, and that's where adaptability comes in.
Right.
Researchers are looking into things like continual learning, where the LLM is constantly updating its knowledge
Yeah.
as new data becomes available. It's like giving the LLM a never-ending education in GNSS interference.
The continual learning.
Yeah.
That sounds pretty groundbreaking.
It's a very promising approach,
Yeah.
but there's still a lot of work to do
Right.
to make sure these LLMs are truly reliable in real-world scenarios.
Of course.
But even with those challenges, the potential here, it's undeniable.
Yeah.
This research is a fascinating look into a future where AI could play a crucial role in, keeping our GNSS systems stable and reliable.
So we've got robustness, adaptability. Those are the keys to making these LLMs really effective out there in the wild. And it sounds like researchers are making good progress.
They are, yeah. And there's another really interesting part of this research.
Yeah.
I think you'll find this particularly intriguing. It's how they tackle the problem of training the LLM on data that really mimics, real-world GNSS signals.
Oh, now you've got me hooked. What'd they do?
So they went beyond just those, like perfect GNSS signals. They actually added a whole bunch of different interference scenarios to the data.
Oh, so they kind of threw in some curveballs
Oh.
to see if the LLM could handle it.
Exactly.
Clever. So what kind of scenarios did they use?
Well, they use data from all kinds of different environments, like open areas, urban canyons, like those areas between tall buildings, even highway settings. And they messed with things like the signal-to-noise ratio,
Right.
the bandwidth of the interference, even the type of GNSS receiver. They really tried to mix it up.
So, simulating all the different ways that GNSS signals can get distorted out there in the real world.
Yeah, exactly.
Did it work? Could the LLM actually handle all that?
That's the really cool part. By training it on this messy, diverse data set, the LLM developed a much more robust understanding of GNSS interference. It wasn't just memorizing patterns. It was actually learning to generalize, to adapt.
So even when it ran into, a new kind of interference or a really tough environment,
Yeah,
the LLM could still make accurate judgments.
it could. It's really a testament to the power of using real-world data for training.
Yeah?
The more diverse and the more challenging that data is, the better the LLM becomes at handling, the unexpected.
This is making me realize, how complex this whole thing really is, all the different factors that can mess with GNSS signals.
A lot to consider. Yeah,
It's pretty incredible to think that, LLMs might be part of the solution.
it is, yeah. It really shows the ingenuity of the researchers, pushing the boundaries of what we can do with AI and finding new ways to apply it to these real-world problems.
Absolutely. Well, we've covered a lot today. We talked about how LLMs could revolutionize GNSS interference detection. We dug into prompt engineering, and we saw how important it is to use, real-world data to train these models.
And as we're wrapping up, I'm feeling pretty optimistic about the potential of LLMs, but also I think a healthy dose of caution is important.
Right.
We need to remember it's still a young field.
Of course.
There's a lot of challenges ahead.
Absolutely. We got to make sure we're developing and using these systems responsibly.
Exactly.
But if we do, the possibilities are just amazing.
They really are. Imagine a world where GNSS interference isn't this huge problem anymore, where our navigation systems they're rock solid, and where AI is helping us navigate this increasingly complex tech world.
That's a future worth working towards. And research like this, it makes me think that future might be closer than we realize.
Yeah, I agree. And on that note, I think we'll leave our listeners with this. If LLMs can learn to understand GNSS signals, figure out all those complexities.
Right.
What other kinds of challenges could they help us with? What other mysteries could they unlock? The possibilities really are endless.
That's a great point. It's a good reminder to keep exploring, keep asking questions, keep pushing the boundaries of what's possible. Who knows what amazing things we'll discover. Until next time, happy navigating, everyone.